everyone, welcome to Aspire Max. This video is about finding exact trigonometric ratios for 30° and 60°. So to find the exact trigonometric ratios for 30°, 45°, 60°, we take a special right triangle. So we have such that two special right triangles with specific angle measures. So one with 30, 60 and 90°. The another special right triangle is with angle measures 45°, 45° and 90°. So to evaluate for 30° and 60° trigonometric ratios, we take an equilateral triangle. So equilateral triangle is with have same angle measures, that is 60° and same side measures. So here we are going to take 2 centimeter equilateral triangle. Then we split into the two halves. So this 60° becomes 30, 30. Okay, and the length 2 centimeters become 1 centimeter and 1 centimeter. So such that one triangle we'll take here. So it becomes a special right triangle, that is with 60°, 30°, 60° and 90°. And here the hypotenuse becomes 2 centimeters. So hypotenuse is the longest side of the triangle and which is opposite to 90°. And here B becomes 1 centimeter. So that is a half of this 2 centimeter. And here A we have to find. So we are going to find it by Pythagoras theorem. So the Pythagoras theorem is it states that in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of other two sides. So here A square plus B square is equal to C square. So here A square we keep as it is. So for B square it is B is a 1, so it will be 1 square. And C square is a, so C is the 2, so it was C square 2 square. Now if we evaluate for A square, that is a 2 square minus 1 square, that is 2 square is a 4 and 1 square is a 1. So 4 minus 1, which is equal to 3. So here A square is equal to 3. But we need here A. So we apply square root for both the sides. So square root of A square becomes A and square root 3. So A is a square root 3. So with this help of special right triangle, we are now going to evaluate for 30° and 60° trigonometric ratios. So in my previous video, I have explained about how to find for the trigonometric ratios of sine, cosine, tan, cosecant, secant and cot. So we have one useful way to remember it. So ka to. So means sine is equal to opposite side by hypotenuse. Ka means cos is equal to adjacent side by hypotenuse, and to means tan is equal to opposite side by adjacent. Okay, so now here we are evaluating for 30°. So when you are evaluating for 30°, you have to, with respect to the angle, you have to decide which is the opposite side and which is the adjacent side. So for 30°, the opposite side, that opposite to angle 30° is here 1 centimeter B, and the adjacent side to the angle 30° is A, that is square root 3 centimeter, and the hypotenuse is a 2. Okay, so first of all sine 30°, that is a opposite by hypotenuse, that is a 1 over 2, and cos 30° is adjacent side by hypotenuse, that is root 3 over root 3 over 2. Then tan 30 is opposite by adjacent, that is a 1 over root 3. So here we can rationalize the denominator by multiplying numerator and denominator with the square root 3. So uh, so 1 times square root 3 becomes square root 3, and square root 3 times square root 3 becomes 3. So we can write 1 over square root 3 or square root 3 over 3. Okay. Now we have for to find the exact values for cosecant 30, secant 30, cot 30. So these are the inverse trigonometric ratios. So cosecant 30 is inverse to the sine 30. Okay, so you can write inverse of 1 by 2 is 2 over 1, and secant 30 is inverse of cos 30. So you can write 2 over square root 3. Okay, so here also you can rationalize the denominator by multiplying both numerator and denominator by square root 3. So it becomes 2 times square root 3 becomes 2 square root 3, and square root 3 times square root 3 becomes 3. So you can write either 2 over square root 3 or 2 times square root 3 over 3. So cot 30 is inverse of tan 30. Okay, so 1 over square root 3, you can write square root 3 over 1. So it is a square root 3. Okay, so now we have to evaluate or find the exact trigonometric ratios for 60 degree. So again, with respect to the angle 60, we'll decide which will be the opposite side and which will be the adjacent side. So the opposite side to the angle 60 is square root 3, and the adjacent is 1. So sine 60, and the hypotenuse is a 2. So sine 60 is a opposite by hypotenuse, that is square root 3 over 2, and cos 60 is a adjacent by hypotenuse, that is 1 over 2, and tan 60 is a opposite by adjacent. So opposite to the angle 60 is a square root 3, and adjacent to the angle 60 is 1. So it is root 3 over 1. Now we'll find for cosecant 60, that is inverse of sine 60. So you can write 2 over root 3. If you want, if you want, you can rationalize it by multiplying root 3 over numerator and denominator. So that is 2 times root 3, and root 3 times root 3 becomes 3. Now secant 60 is inverse of cos 60, that is a 2 over 1, 2, and cos 60 is inverse of tan 60. So it is 1 over, so it is a 1 over root 3. So here again you can rationalize the denominator. So 1 times okay, you can multiply both numerator and denominator by root 3. So it will become 1 over root 3, that is 3. 1 times root 3, that is 3, and root 3 times root 3, that is a 3. So cot 60 you can write 1 over root 3 or root 3 by 3. Okay, so please subscribe my channel. Okay, so in next video we'll evaluate for 45 degree, 90 degree and 0 degree trigonometric ratios, and comment if you have any queries, and subscribe to my channel. Thank you.